In looking at discrete probability distributions and expected value, several students have been asking questions about it, and I understand that this is a very hard unit in 152, so I'm hoping that this will help a little bit and give you guys some examples. So what is a probability distribution? That's kind of where you need to start. A probability distribution assigns a probability to each value of a random variable, and it can be represented using a formula or a graph, but we are going to be looking at tables right now. So a discrete probability distribution must satisfy all three of these requirements here. So it can't just be one, it does have to be all three. So the random variable is numerical, and the values have corresponding probabilities. So that value has to be numerical. It cannot be categorical. The sum of all the properties of the random variable is 1. So when you add up all of those probabilities, it should equal 1. If it does not equal 1, it is not a discrete probability distribution. And each probability of the random variable must be between 0 and 1. So, and that includes being 0 and 1. So all three of those have to be true. So the first example that I did in your soft chalk lesson in Blackboard was this guided example on building a probability distribution. So consider the following scenario. You're going to flip a coin 4 times. We are creating the probability distribution for the number of tails flipped. So this number of tails flipped is really what we're focusing in on. And because it is the number of tails flipped, we will have a random variable that is numerical. So what is our random variable x? It is the number of tails flipped. And then this next part asks you to actually write the sample space for this event. So that's saying, what is every possibility of these 4 coins being tossed? So let's see if I can make this a little bit bigger so you guys can see it. So if I start with this, I could have heads, 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 and then heads, 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 tails, heads, heads, tails, heads, heads, tails, heads, heads, and then tails, heads, heads, heads. And you're going to have to do that for every possibility. So the next one would be, well, what if 2 pieces are tails? So we have heads, heads, tails, tails, heads, tails, heads, tails, heads, tails, tails, heads, tails, heads, tails, heads, and tails, tails, heads, heads. Okay, and now what if it's 3? So heads, tails, 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 heads, tails, 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 heads, tails, 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 heads. I missed one that had a 2 in it, so that is T, H, H, T, and then of course T, 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 T. So that should be 16. How do I know that I needed 16? Well, that's because if you remember back to one of the earlier lessons in Unit 2 in 152, you would have learned that we have 4 flips, and each flip has 2 possibilities. So 4 squared is 16. That's how I know I need a sample space of 16 events. Now I can look at creating the probability distribution for this using the sample space. So I'm going to make this where we can fill in this table. So we have, of course, that x is the number of tails. I'm going to just write it as t. And then we're going to have our probability. So how many times do we get no tails? Well, that only happens 1 out of the 16 times. How many times do we get 2 tails? So then you're going to need to go up here and count. So I've used my heads. So now how many times do I get just 1 tails? So there's 1, 2, 3, 4. So you should have 4 out of 16. And then let's take a look at, okay, well, how many times do I get 2 tails? 1, 2, 3, 4, 5, 6. So that's 6 times out of 16. How many times do you get 3? So we're going to go back and count that one as well. So I get 3 tails, 1, 2, 3, 4, 4 times. And then we get, of course, 4 tails only once out of 16. And then you could put these probabilities into Excel and it would give you a decimal answer. But you can work with these also as they are. So let's go back over this discrete. We know that being discrete probability distribution, the random variable is numerical and that the corresponding values have probabilities. Well, if we look at this part C down here, I see numerical values, corresponding probabilities. Now, if I add up all of these probabilities, should I get 1? Yes, you should. 1 plus 4 plus 6 plus 4 plus 1 gives you 16, and that's 16 over 16, which is 1. So the sum of all the probabilities is 1. That's true. And each probability of the random variable must be between 0 and 1. So each of these is a fraction, which means they are more than 0 but less than 1, so that is also true. So this is a probability distribution, and you're able to set up the table. Now here's some questions. 2 of these is in your Blackboard assignment, so I'm not going to do those. But you should be determining why the following scenarios are or are not probability distributions, and you want to make sure that you take a look at all of those guidelines that we have. So if we look at number 2, we have the probability distribution for a number of times that the number 1 was rolled when a die was rolled 4 times. So the first thing you want to look at, is this random variable numerical? Yes. Does it have corresponding probabilities? Yes. So number 1 is checked off. The sum of all the probabilities of the random variable is 1. If you add these up, you should get 1 in this case. So yes, all of the sum of the probabilities of the random variable is 1. The third thing to look at is each probability of the random variable is between 0 and 1. That is also true. All of these are between 0 and 1. So is this a discrete probability distribution? Yes. And again, you would go through all 3 of those cases that have to be true. So expected value of a discrete random variable. So what is expected value? It is equal to the mean value of the outcomes. So expected value, you will see it denoted as E of X. And remember that E of X equals mu. Okay, mu is our mean. So to calculate the mean of the discrete probability distribution, we will be using the formula that the sum of all of the x times the p of x. That will give you your expected value. Okay, so let's look at one by hand, and then I will try to post an Excel video of one as well. So using the data in the table below, calculate the mean of the discrete probability distribution. So the first thing you need to do is you need to find what is x times p of x. So all you're going to do is be multiplying these values. So what is 1 times 0.135? So you should have 0.135. Same thing for the next one. 2 times 0.08. So 0.16. And I'm going to do that all the way down. So this is 0.78, 0.88, and 0.915. Okay, so again, your formula there was just x times p of x. Now you're going to determine the sum of these products, and that will give you your mu. So let's just make a note here. What we know, we are looking for E of x. E of x is equal to mu. Mu is the sum of all x times p of x. So all I have to do now is add up this column. In Excel, that's super easy. So I'm going to just make a note here, and then like I said, I'm going to try to show you guys one later. So the sum of all x times p of x. So I'm just going to write in here E of x equals, and if you add those up, you should get 2.87. I want to show you guys some of these in Excel because that will make it a little bit easier. Number 2 here is part of your Blackboard assignment, so make sure that you feel comfortable with that. But either 1 or 3 for your for you to see in Excel, and then that way you have a chance to do another one. We'll do